Hi everyone, this is Mr. Roix. We're going to take you through the last two dimensional analysis problems from the worksheet we dealt with the other day, problem 15 and 16. I know you guys are starting to get tired of dimensional analysis, but believe me, the effort you're putting in now will make a difference in being able to solve problems later on. So let's go to the first problem. The first problem was talking about a pound of butter. Doesn't give us very many details, so we're just going to say it's 1 pound of butter. It's talking about density, and or it's asking what the density of the butter is. I guess through the questioning of whether or not the butter will float in water. So we're comparing it to the density of water. Things to remind yourself when we're talking about density. Density is equal to mass over volume. And when we're talking specifically about the density of water, you should hopefully already know the density of water to be 1 gram per centimeter cubed. Alright, so someone is apparently going to throw some butter in water. I'm not quite sure why, but we're going to calculate it out rather than actually waste a pound of butter. And so here we go. We have 1 pound of butter. It tells us the dimensions of the butter. And remember that we can solve for volume by multiplying width times length times height. Not really sure why I started with width, but anyway, it's usually length times width times height. It's all the same. It's multiplying. And so the values they give us, are 6.5 times 6.5 times 12.0. That's a decimal point. And that's in centimeters. So we have pounds per centimeter, and when we multiply all those centimeters together, we're going to have centimeters cubed. So the label on the bottom is going to be just fine for us, and we just have to worry about the label on top. We need to get it out of pounds and get it to grams. So how do we go about doing that? We're using the conversion factor that in 1 pound there are 454 grams. Alright, so now what happens is the pounds label is canceled, and as I mentioned before, the label that we're going to use from the bottom, and I'll show you how we get this, we're going to end up with, we'll just show you in this bracket here the answer of the multiplication, that we're going to get an answer here of 507 centimeters cubed. Alright, the 454 comes across. And so, in order to relate this to the density of water, which is, again, this value of 1 gram per centimeter cubed, all we divide is 454 by 507. And what that ends up happening is it gives us a value of, and I don't know if I have the exact number in front of me, but it's approximately 0.89, and it might be 893, give or take. Again, if we base it off of our 1 pound value, that means we have one significant figure, and so we would round that to a value of 0.9 grams per centimeter cubed, which gives us a density less than 1, and therefore is going to be able to float in water. So we know the answer to that question. Alright, so we're going to continue on. We're going to do the next question. Next question is another question that involves derived units. And so let me just erase all this. Alright, so it's telling us that we have a recipe. It has the metric measurement of 0.5 kilograms of milk, I believe, in this particular problem. And it wants us to determine in ounces, how many ounces of milk is 0.5 kilograms. I said 0.5, but I mean 1.5 kilograms, as I wrote down here. And so again, when we're solving these types of problems, at one point they give us in the problem a density of milk being 1.03 grams per centimeter cubed. Just as an aside, whenever you're given values that are derived units like that, like density, that's going to be used as a conversion factor a little bit later on in this problem. So first step is we want to eventually solve for ounces. So we need to get this out of our mass, and we need to get it to a volume, and that's where the density is going to come into play. So if we use the conversion factors that are given to us on the sheet, we can, in some of which we need to know just in terms of metric conversion, we have, 1 kilogram is going to be 1,000 grams. Now we have it in grams. Now we can use this density value right here. And so what label we want to get rid of is a gram label. So the gram label is down here. So when we think about density, we usually think of it as written as 1.03 grams per centimeter cubed. And we don't write the 1, but it is 1 centimeter cubed. Now, what's the difference between me saying that and then going over here and saying, well, if I have 1 centimeter cubed of milk, what's the mass of that? Well, it's 1.03 grams. So these ratios are exactly the same. So that allows us to put the ratio, this ratio right here, up top. We're going to put it in here. We'll have 1.03 there. And then if we come up here, we're going to have a value of 1 centimeter cubed. Now that we have it in centimeter cubed, we can use the very important conversion factor between metric volume, metric volume and liquid volume for the metrics. So we can say 1 centimeter cubed is 1 milliliter. Now we got it in milliliters. We're getting closer to our ounces. Now we have to go through liters. So we can say there are 1,000 milliliters in 1 liter. If you follow me along now, we're next going to go from liters to quarts. So we can say 1 liter is 1.06 quarts. Again, this is all from the conversion factor sheet that you don't need to memorize those. And so next step is, now that we have it in quarts, we can go directly to ounces. And hopefully you know that 1 quart contains 32 ounces. Alright, so we do all that work there, and now it's just a matter of multiplying everything. And so we're going to have 3 significant figures in our answer. We do all the math here. Again, cancel our labels because we know they cancel. Kilograms cancel kilograms, grams cancel grams, centimeters cubed cancel centimeters cubed, milliliters cancel milliliters, liters cancel liters, quarts cancel quarts, and our answer will be in ounces. And I believe, if I remember my value correctly, we end up with 49.5 ounces of milk. Milk. Sorry, it's an I. Alright. So anyway, I hope that that helped you out with those 2 problems. Certainly, like I mentioned before, if you need some extra help with this, please make sure you find time to come see me. We'll make things much easier for you as we continue on if you're able to work through these problems without too much of a hassle. Alright, thanks. We'll see you in class.